Hey y'all, in this lesson we are taking a look at being able to find distance on the coordinate plane. Our I can statement is I can use the Pythagorean theorem to find the distance between 2 points in the coordinate plane. Our essential question then is, how can you use the Pythagorean theorem to find the difference between 2 points? Remember that the Pythagorean theorem states that if a triangle is a right triangle, then our formula of a squared plus b squared equals c squared is true, where a and b are the legs and c is the hypotenuse. We're first going to look at a little situation. Thomas says that walking along a straight path from the haunted mansion to the clown tent, so you can see these here, haunted mansion to the clown tent, is shorter than going the yellow path. How can you use the Pythagorean theorem to determine whether he is correct? Well, we have plotted and labeled the locations of these stars on our coordinate plane. We'll use these two as vertices and draw a right triangle. So, if we have a coordinate plane, like so, this represents the space that is kind of right here, represents this space here in our graph. And you can see how we have made this triangle, and it is a right triangle because straight down and straight over makes a 90-degree angle. Using the Pythagorean theorem, we can see that the length of the bottom is 1, 2, 3, so we get 3, and the length of the side is 1, 2, so we get 2. So we use 2 and 3 as A and B. 2 squared is 4, and 3 squared is 9, so we have 4 plus 9, which is 13. Finally, we use a calculator to help us take the square root. The square root of 13 is about 3.61. So walking this straight path from star to star would be 3.61 units. We have to go back to our problem and see how these units convert to figure out how much distance there is. So again, looking at the scale, 1 grid equals 1 centimeter by 1 centimeter. So that's 1 unit. And each centimeter is 500 feet. So we have 3.61 centimeters, and then we got to figure out how many feet that is. So 1 centimeter per 500 feet is the same as 3.61 centimeters per how many feet? We're setting up a proportion. To go from 1 to 3.61, to go here, we are multiplying by 3.61. So to get our answer, we're going to multiply 500 by 3.61. 500 times 3.61 is 1,805. So it's 1,805 feet directly from tent to tent, as opposed to going the 5 centimeters or 2,500 feet that Jim walks. Because if they were to, let's back up here, if they were to go down 2 and over 3, they have to walk 5 centimeters, and 5 times the 500 feet is how we get 2,500 feet. So Thomas, who says it's shorter to go straight, does walk a shorter distance than Jim, who walks the yellow path, and he walks 2,500 feet. So we used the Pythagorean theorem to find the distance between points on a coordinate grid. You try. What's the distance between A and B? Make sure you put in a triangle, find the lengths, and calculate the hypotenuse. Try this on your own, then press play to see the answer. We'll use our Pythagorean theorem. Plugging in 2 and 2 for A and B, we get 4 plus 4, which is 8. The square root of 8, when we use a calculator, is about 2.8284. So the distance is about 2.8 units. Let's look at example 2, finding the perimeter of a figure. So if we want to find the perimeter of a triangle, we need to know all 3 side lengths. The height and the base are easy. We can just count. This is 3, and this is 1, 2, 3, 4, 5. But what is the length from A to B, or the hypotenuse of our rectangle? We have found sides 3 and 5 for our AC and BC, and now we'll find the length of the hypotenuse. We'll use our Pythagorean theorem, plugging in 5 squared. This should be 3 squared. Sorry, that came out weird. This should be 3 squared. 5 squared is 25, 3 squared is 9, 25 plus 9 is 34. This is the same. They just set up the c squared on the left and the other parts on the right this time, but it's still the same. We're still going to find the square root, and when we use our calculator to help us, we get 5.83. So now we know that this length is 5.83. Now we can add up all three lengths to get our total perimeter. So the distance is 5.83, then the perimeter, there we go, is 5 plus 3 plus 5.83. So adding up all three of those lengths, we get 13.83. So the perimeter, the answer to our problem, is 13.83 units. You try. Find the perimeter of this triangle. These points just tell you the points that are marking the triangle vertices. You need to find the distance between each point and then add them to get the perimeter. Try this problem on your own and then press play to see the answer. In this problem, our height here is going to be 6 and our length here is going to be 3. We just need to find the We just need to find the distance that is the hypotenuse. So we'll use our Pythagorean theorem. 3 squared plus 6 squared is 9 plus 36, which is 45. And we take the square root, we get 6.7. We'll add those together. 6.7082 plus 6 plus 3 is 15.7082 is our final answer for the perimeter of this triangle. Our final example is going to use the Pythagorean theorem to solve different problems on the coordinate plane. Lee draws one side of an equilateral triangle with vertices at -1 and +1 and 3 +1 on a coordinate plane. The third vertex is in the first quadrant. What are the coordinates of the third vertex? So this is going to require us to draw a picture. We know that here is those 2 points they gave us graphed, and the distance between them is 4. Because this is an equilateral triangle, we want to create two sides that are also a length of 4. So whatever point this ends up being, we want these two sides to have a length of 4. So we'll use the Pythagorean theorem to find the height to the nearest tenth. So here again is that set up. Again, it's 4 across the bottom, which means it's 2 across the side. And we know we want it to be 4 along the other side. So that we can, by putting in the height, we create this right triangle that we can find out what the height is. And you'll see how that helps us later. So we find the height of the triangle. We plug in 2 for B and 4 for C. 4 squared is 16, 2 squared is 4. We subtract that to get 12. So the height is the square root of 12, which when you put it into a calculator is about 3.5. Now that we know that A is about 3.5, we can use that height to help us determine what is the point. So again, here is the original drawing we did. The height is 3.5. So if I go up 1, 2, 3.5 units, that should be the correct height of my triangle. Now I'm doing it right in the center because 2 units and 2 units on either side. So we should be putting a point at up 3.5 units. So you can see there 3.5 units up is where we put our point. This is at 1 on X and halfway above 4, 4.5 on Y. So that would create our triangle that is equilateral. The point, the coordinates of the third vertex is 1, 4.5. To summarize, you can use the Pythagorean theorem to find the distance between any 2 points. Draw a right triangle where the length you're trying to find is the hypotenuse. That will give you an easy to count A and B, and then use the Pythagorean theorem to find your C. Your next steps are to submit your 8.3 notes, complete your 8.3 practice, and take your 8.3 mastery check. This was the last lesson of the unit, so next up will be our quiz. Good luck.